Alright, I'm going to try to fix my lathe here. I got to do some fancy machining here, so I got to get my tools squared away. So I found out my lathe center's all out of whack. Right now I'm turning the bar stock around and rolling, so I can see where my machine's going here. And right now I'm trying to get this, to see how even my machine cuts with just holding the vise. You think everything runs true and straight on these things, but they don't. They move around all over the place. Transverse across the face here, you'd think it'd be going perfect perpendicular to the, or in parallel I should say, to this surface here on the spindle. So that means the head of this machine has to be square to your table. And yeah, that doesn't always work out that way. Where's my mic at? Okay, that was a 3.5/4 thou pass there I made, so looks like I've cut about 3 or so on this side. So we're about 6.5 up there on the mic, if you can read it. And we're at 7 3/4. And down here we were at 8 1/4. 6.5 down here. Turn it 90 degrees. 6.5 again, so we know it's round. Seven 3/4, and this should be 8 1/4 down here. Yep, pretty much what it is. So 6.5 to 8 1/4, it's 1 3/4 thou. Out of square. And if you think it's cutting different because it's way out here, yeah, it should be cutting bigger out here because it wouldn't be cutting as much. It's actually cutting more out here than here. So that means our head in here is not square to our table. How do you fix that? You don't. That's how you fix it. It's on the floor. So this is all bolted onto this, and who knows how good that is. Actually, I still got oil in here. These things run dry, but it's been there for a year now. Guess I finally filled all the leaks up. Alright, so we got a problem already. The machine itself is not very good. So I don't really have a way of fixing that problem. So I'm not sure how you would do that. All you could do is loosen these bolt holes up here. See if there's any other ones somewhere else that you can loosen up. Probably not. Down there in the bottom was fit. Turn the light on. Bolt holes down there? Not that I see. Of course, all I see is a bunch of fluff off the belt. Like way down there. Is there a bolt down there somewhere? Not that I see. Yeah, it's a lot of fluff. Alright, well I know there's more than 2 bolts holding this thing together, but who knows where they're at. So you could try loosening those up and yanking on it this way and see if it'll move. Yeah. Don't think that's going to have much effect on anything. But that would be an option. Alright, next problem is this center is not parallel to what this is at all on center line. Now you can adjust this side to side with these screws because this is on a dovetail here, so you can move it back and forth. So you can compensate for an air going this direction like this. What you can't do is you can't do anything for elevation. And that's where our big problem is. Alright, so I'm going to go ahead and face this off right here and put a center hole in it. So I got something's on center right now is what I'm using. Because right now we just got done cutting that, so I know where I'm at. Fall over, let's drop that way down a little bit. Okay, so we got a little, kind of see what I'm doing a little bit. Quiet now. Drill chuck down here. So this in here. Grab the center drill right here. Drill it. So now we have a center hole. Take the drill chuck out, put our center back in, and we'll see what we got. So right now, this hole here should be on center, not moving. Looks pretty even to me. Okay, so we know that's not moving. Now you come across this thing here, put it right into here, tighten the jam down so it's full tight. Take up the screw lock right here to take up any clearance in your shaft right here, and you screw it on in. And you look at the center going in there, and if you look at it, watch it go up. So do you see it going up there? So it raises it up a little bit. Not a lot, a little bit. Well, the other one I did was a big difference, but this is all turned and trued. That's what we have. Okay, so now we got to do with my cow. It's over here. Where I was using it last. Okay, if I'm going to put this on here, I'm going to put that up on the part and see what we can get. Let's see, right now we are way in the way. Everything's going the wrong direction. Typical. bad direction because you can't see what you're doing over here. But it is what it is. Okay. So right now we're going to measure side-to-side movement. You can also measure taper like this by going all the way down. You can see where the dial's at. Say you lose about a thousandth. So 1 thou on that means you take 2 thou off the diameter. That's our 1 3/4. So the indicator is showing the movement as being out. That also means that this is going nice and square till we cut, which makes sense because it's connected to it. And the air is the relationship between the lathe truck spindle here is not square to the bed of the lathe. So this head here is cocked a little bit. And it's cocked, let's see, it's cutting more on this side, so it's pulled out. So it needs to go that direction, which is the opposite of all the cutting force, so it's kind of the opposite way you would think it would be going. You think it would be pushed away, taking up all your clearances, and that would make this side bigger, not smaller than this side. So it's actually opposite what it is. So it's pretty much been this way forever, probably. We've had this lathe since 76. Piece of crap. It's been a piece of crap its whole life. Okay, now you take this and we run it in here and see what happens to the indicator. Does not look like it's making any difference at all. I don't know why we're getting out of round condition because it's turned round. Okay, so this is not showing any indication of moving in that plane. Alright, so that part looks good. Okay, now we're going to turn it 90 degrees and check the top plane. It's a lot better than it was last time I checked with I used a Harley axle. I'm thinking that the Harley axle might not have been super on center. Okay, we're getting about the same 1 thou movement. Let me go from one end to the other. We'll put this on 90. So you can see how we're 1 thou under right there. Oh. Don't go too far. Don't be looking at the indicator, not what you're doing. Oops. Okay. So now we're going to turn that light off. Might help, I don't know. So 0. And we go all the way down to about there. Before here, we're about 1 thou down. Back up. And we stabilize about 1 thou. Okay. Now let's see how we tighten this up over here. We'll tighten the center up and see what happens. Okay. See how we moved it up? Okay, that's your error in your center line. It's got 3.5 thou. Zero this out. Yeah. 3 1/4. So when we tighten this thing up here, we go up 3 1/4. And we get everything locked up right here, so it hasn't moved any. And we assume we're going up. Yes, we are going up. So this center is high, not low. So it's lifting the bar up. So that means this center needs to drop a little bit. So if you put a shim under here, theoretically you can drop it. The problem is that distance is over 1 foot, or about 1 foot. So whatever you do right here is going to make a big difference up there, because the pivot point is going to be right here next to you. So you're not talking much of a difference in height between these two surfaces to make it change that 3 thou over there. So if I try to put a shim under here, I don't think I'm going to gain much. I'm going to gain way too much of a change, I think. But I don't know. You don't know until you try it. And I'm not sure how this thing exactly comes apart, which is a whole nother problem. Now there might be something else stuck in here. I doubt it, because this thing doesn't really move. Could be a little chip or something in there, who knows. So how do you make this thing move up just a... The air is half what you see, so if it's 3 thou out, it's 1.5 thou. So how do I get a 1 1/4 of a thou, or 1 1/8 thou change when you're making your change right here? Or this has to come down. The only way this is going to come down, it has to be ground. So I don't see that happening too much. Alright, so we need to pull this thing out and see what we can do here. What are we going to do to fix this problem? First thing I do is loosen this up. These are 2 set screws. They force each other inwards, and that's what locks it. So that's what moves it around a little bit. Okay, let's get this out of here. There's a lock screw up underneath here. Buried up under here. Yeah. Arm doesn't bend too good that direction. It appears to be damaged. Yeah, not going to just fall out of there. Some kind of a metric size, I'm sure. I'm going to try a big socket, see if that's close to what it is. It's bigger than 7/8. way so I don't bump into it. So I'll use a 1-inch socket this time. Okay, that'll work. Flange nut. Probably a 15/16. There's a plate that holds up underneath the way. It basically just pinches it together. Oh, it comes right apart. I didn't know that. I didn't know that was going to fall apart like that. Okay. Totally different than I thought it was going to be. Okay, and this just lifts off of that. Pretty simple. So this here, rusted stuff here, is where we're high right now. So if we clean this up a little bit, it might make it look better. Not sure what the 8 means. It means something to somebody. Alright, so there's all our different tools here. Now these threads here have been pulling out for a while now, and you can see all the threads are just about done. This needs to be replaced with a lot stronger setup than we have here. This is a grade butter bolt, and it was just yanking the threads out. So when you try to tighten this thing up, it doesn't stay tight anymore. And these threads in here appear to be okay. It does not look like a 1/2-inch thread, but it might be. If it is, we have stuff over here we can use a 1/2 inch on. Appears to be a 1/2 inch. Okay. So we can use a big one of these right here. I got a whole bunch of these things sitting there. Take one of these and cut and weld this together and lengthen it, make a new one. We just got to measure our length here and see how much length we need. Obviously this one's too long. So these are heat treated bolts. So this being 1/2 inch thread, we can use a big coupler nut to tie these together, assuming this is threadable, which I'm sure it is because it's so soft. It looks like it'll probably do what we need to do. So the problem is coupler nuts are not very heat treated either. No matter what you do, there's always something in the way around here. Oh, first drawer, look at that. Bunchy cord's not helping. Because the other thing I would do, I'd take an Allen bolt like this, cut it, weld that sucker on there, and hope for the best in your weld quality. Chances are I'd probably pull. Okay, these are coupler nuts. Guess why they call them coupler nuts. Yeah, they couple parts together. Okay, this is hard to do by, that looks like a 1/2 inch to me. Okay, this is a thin 1/2 inch. They also make thick 1/2 inch ones. That's not these. That probably was in this drawer over here. Now these are also soft. These are not heat treated very well. So I'm not sure how much better these would be than what I have. But over here, these coupler nut here are heat treated. And we have a few in here we're not using. Here's a brand new one right there. So that's the difference between a good one and a crappy one. I'll probably need a stud that's about that long. I don't have a lot of those. You probably take one of these and shorten it. Possibly use that. Alright, I'll be back.